Hello everyone, welcome to my YouTube channel Shilpa Data Insights.
In this video, we are going to discuss about different sorting algorithms. That is, the first one is the selection sort. In the last video, we saw about the linear search and the binary search algorithms. So let's begin with the selection sort. What exactly is the selection sort? First, we will understand. Let's say we are given an array here with length is equal to 5, right? The number of. So if you will see, now the array is not in the sorted order. What should be the sorted order? It should be 2, 5, 7, 12, and 20. By just looking at it, you can just let us know that this is the sorted array. But how you can go ahead and program it so that the programmer or the computer can know how to exactly sort this particular array. What could be the logic behind it? First, go ahead and get some rounds. Rounds means there are some rounds on the basis of which I will be sorting the array. So in the first round, I will be getting my smallest element out of the array, and then I will be placing that particular smallest element in the right place. Right place means, let's say this is the 2, right? So I need to place my 2 in my first index. So I need to go ahead and have my rounds. In each round, I will be calculating the smallest element, and then I will be swapping that element with the required element in order to get my sorted array. So this is my actual algorithm that I will be going ahead and explaining you. In the round 1, what will you see? In the round 1, you need to first get the smallest element out of the complete array. The smallest element here is 2, right? So what I will do is I will swap this element 2 with my 5 to get my smallest element at index 0. Okay, so my smallest element is 2, so I will have 2 and I will swap it with 5 and get my required. Now I have to sort the rest of it. So now in the round 2, that is, I will have 2. Now I will check in the rest of my array. My next is 5. So 5 is in the sorted place, so I will be swapping it with its own. Then I have 20, then I have 7, and then I have 12. So my round 2 is complete. Next, in round 3. In the round 3, I have my 2, I have my 5. I will be looking at the rest, that is till this, which one is my sorted portion. This is my sorted right now. I have to look at the rest of it. Okay, so in the rest, I can see 7 is my lowest, so I will swap the 7 with 20, and then I have 12. So till this match now is my sorted array. Now I need to sort these two portions. In my round 4, I have 2, 5, 7. Then I will swap these two to get my round, and this is now sorted, and I'm left with next one. So my round 5 will be what? I have 2, 5, 7, 12. But now I am left with only the last element. So do I need to sort this? This will be the largest element in the array itself. So I don't need to sort it. So I will have this. So my round 5 is actually not required. Okay. So I will remove this round 5 from my list. So how many rounds do I need if my length is 5? I got 4 rounds. Okay. So how will you decide how many rounds is required? So the rounds is basically nothing but your length of the array minus 1. Okay. That is my rounds. So here in the round 1 is I is equal to 0, I is equal to 1, I equal to 2, and I equal to 3. So in this, if you will see, there are 2 things that we are doing. We are calculating the smallest element from the unsorted piece of array, and once we calculate the smallest element, then we are swapping that particular smallest element with the element that we are comparing with. Let us see another example in this case, okay? I'll create a small array this time in round 1, okay? I have to go ahead and get the smallest element. Smallest element out of this particular array is what? It is 11. So I will go ahead and put my 11 in my first index. Okay, so here we have 11. Then we have 25, 12, 22 and 64. Why we have 64 at the end? If you remember, we first find the smallest element and then we swap that smallest element with our index that we are comparing it with. Here what we are considering is, this is my minimum value, okay? And I'm comparing this minimum value with this one. So I will go ahead and swap that minimum value that we thought with this, right? Now, in the round 1, that is I is equal to 0, I got my first element. What I have, I equal to 1. In the round 2, I have 11 by its own. Now, my comparison is 25 with my rest of the elements in the unsorted array. Okay. So now if I see in this unsorted array, 12 is my smallest element. So I should compare 12 with 25 and swap it with 25. Okay. So now I have here 12 and I have here 25, 22 and 64. So these two things are now swapped. Now let's say in round 3, I equal to 2. What will happen? These two are sorted. Okay. Now I need to concentrate on this part. Now if you will see, 25 is my minimum index. I have to compare 25 with my rest of it. Now I see 22 is the minimum. So I should swap 22 with 25. So I have 11, 12, 22, 25 and 64. So now round 3 is complete, in which I have my sorted array till this much. Now I need to concentrate on 25 and 64 in my next round. In round 4, I have I is equal to 3. Here I have 11, 12, 22. Now, if I see, I have to compare these two. Now, I see 25 is the lowest, so I will keep the 25 as it is and 65. Now, this is my sorted array and only one is left. So, this is also my sorted, which is my largest. So, in all of this example, we are actually doing an ascending order sort. Okay. So, this is our prerequisite that we are doing. So, now, if you need to code this, how exactly you can code it? So, you have seen there were 2 iterations that we were doing, 2 types of iteration. There is one loop in which we are going ahead and checking the smallest element, and there is another loop in which we are actually, after checking the smallest element, we are swapping that particular element. Okay, so let's say this is our I and we are assuming that this is our minimum index. So whatever value we have in this particular index is our minimum index. Okay. So at minimum index equal to 0, my first smallest value is residing. Once we have assumed it, we have to compare it with our rest of the element, whether that is correct or not. Okay. So for that, I will go ahead and create a for loop. I will start with I, that is the index. Okay. I in range, I'll start with range 0 till what? Till n minus 1. If this is n, then n minus 1 is 4. I have to do it till n minus 1 because I need only 4 rounds, right? So therefore we have 0, 1, 2 and 3 if we mention n minus 1 in the for loop. Now, the minimum index we have assumed as I. Inside this, we have to check what is our smallest element. So I will be taking another loop for j in range what? Range should be I plus 1 till n. If A of j, right, the element that is present in A of j is less than A of minimum index, then the minimum index, we are replacing it with the value of j. Once we got it sorted, then I will come out of this loop and then I will go ahead and swap my minimum index and the I value. That is A of minimum index and A of I. Now if I want to print, then I can print my array. Now in this case, if you will understand here, I have my I, okay? In my first iteration, I will have my I equal to 0. So my minimum index, I'm considering it at this particular location. Now I'm entering inside my inner loop and I'm calculating it from I plus 1 from this particular thing. And I will be checking my value, that is my 64 in this case, right? That is A of minimum index, whether this value is less than this value or not. Okay, if this value is less than this value, then I will replace my minimum index in this location. If it is not in this location, then I will research which one is the minimum. If I find this particular minimum, then it means the minimum index should not be here. The minimum index should be here. So if I see in this particular array, my minimum index is here, right? So this minimum index is not correct. I should point my minimum index at 11. So let's go ahead and make this value as minimum index, right? So once I get this minimum index at this stage, my j value becomes minimum index at this. Then I will be swapping this value with this at this stage. Once I have it, I will again check for I equal to 1. That is here I equal to 1. If I is equal to 1, my range is what? 2, I plus 1. So from 2 till 4, I will check, right? So from 2 till 4, I will check what is my minimum index. Now, my minimum index, I am pointing it to here because my I value is this one. So now I will be pointing my minimum index is here. Now I need to compare this minimum index. This minimum index, if I compare with the rest, I see that this is not right because I could find here as my minimum index. Okay, so this will be my minimum index. So I'm assigning the j value, the minimum index that is at 2, to basically as my correct minimum index. Then I will be swapping it basically. That's how it actually works. Okay, so let me explain you this particular code in the IDE and run it and show it to you. So in this selection sort, I have created a small array. I have my length of the array and I will go ahead and iterate it through the complete loop from the 0 till n-1. And I will assign the minimum index as the first element of the array. Okay, that is I. Then I will go inside this particular loop and check what is the smallest element, whether this is the smallest element or any element among these is smaller than this. If among these any element is smaller than this, then I need to go ahead and reassign my minimum index value to that particular value. So j is assigned to minimum index. Let's say here in this case 2 is my minimum value. So I will be assigning the minimum index to 2. Okay. Once I am out of my inner loop, what I will do is I will go ahead and swap those two elements. That is my 2 is my minimum element among them, right? Among these. So I will go ahead and swap this 2 with my 5. Similar process will go on for the complete array, and I will print the result. Let's go ahead and execute this and see how it works. So I have my this n is length of array, and I will print this particular thing. If you will see, my array is now in the sorted order 2, 5, 7, 12, and 20. Let's say you need to go ahead and see at each stage after the smallest element is found and it is swapped, whether it is giving me the correct result. I can just put my print statement here and I can run this again. So if you will see, this is 2, 5, 20, 7, and 12. In my first run, the second element is the number 2 is actually put in the first part. Next is the 5. 5 is the smallest element. Next among this, 7 is the smallest, right? So I am swapping the 20 with my 7. Okay. In the next round, I see 12 is my smallest. So I'll swap it with my 20. And this is how my final result is displayed. So now we have the full proof that this particular selection sort is up and running. There's no problem in my selection sort. So let's say what is the time complexity now we will check. So in the best case scenario and the worst case scenario. So let's take the best case scenario. Let's say my array is already sorted. Okay, it is 1, 2, 3, 4, and 5. So I will keep this array as minimum index and I will compare if there is any element which is less than this particular element or not, right? Looking at it, I know that it's already sorted, but the computer programmer doesn't know whether it's sorted or not. So it will look up for this. Now, let's say these two are sorted, then he will or she will go ahead and look at the other elements, whether it is sorted or not. So every time it will go ahead and get all the rounds to check the array is sorted or not. So in this case, we have a for loop, okay, in the first for loop, and then we have another for loop, right? If we calculate for both the for loops, we have to check. So the time complexity, if you know there are 2 for loops, then it is O of n squared. How exactly you go ahead and calculate it? So in this, the first element, for that you have to compare it 4 times, right? For the second, you have to compare it 3 times, then 2 times, then 1 time. So let's say array has a size n. So for that, you have n minus 1, n minus 2, and so on till 3, 2, and 1. So if you have learned the mathematics, the formula of this is 1 plus 2 plus 3 till n minus 1. How is it written? It is n into n minus 1 by 2, which is n square minus n by 2. And in big O notation, this is O of n square, right? So this is our big O notation. So now, in this case, the best case scenario is O of n square. The worst case scenario is also the same thing. You have to calculate 2 for loops and you have to get the result. So in both the best case and the worst case, both of them are O of n square. And if you talk about the space complexity, there is no extra space that's needed, and variable actually occupies a constant space. So space complexity is just O of n, and that's. If you think about it, what is the use case in selection sort? If in case the array is small, right, you can use the selection sort. In this selection sort, you will have O of n square complexity, but that doesn't matter because it is small array. But if it is large array, it's better to use other sorting techniques. So you have understood exactly how to implement the selection sort. What is the time complexity of selection sort? What is the use case of selection sort? Now, the major part is you need to go ahead and practice as many questions as you can from different websites. Whatever websites you use to run your code, you can go ahead and practice in that website. The famous GLG Leetcodes, right? Everyone uses that. So you can start with it and start practicing the selection sort. So that is one key fundamental that you have to do in order to go ahead and get used to this selection sort algorithm. This is all that I had. I have created a same video in Hindi language. If you want to check out my Hindi video, then I will pin it in the I button and put it in the description as well. So go ahead and watch so that you have a much clarity exactly how you can use the selection sort. And if you find this particular video helpful, then hit the like button, share it with your friends, and subscribe to my channel.
Thank you so much for watching, and I wish you have a good day.